Welcome to another fascinating edition of Astronomy Daily. I'm excited to bring you today's roundup of the most intriguing developments from across the space and astronomy world. We've got a packed show ahead with stories that showcase just how rapidly space technology and exploration are advancing. We'll be diving into Italy's groundbreaking negotiations with SpaceX for a major telecommunications security deal, exploring revolutionary developments in electric propulsion technology that could transform how we travel through space, and examining some remarkable astronomical discoveries that are changing our understanding of black hole formation. We'll also look at the unique challenges of timekeeping for future lunar missions, check in on the latest updates from Mars, and preview some of the exciting space missions planned for 2025. So let's get started with today's cosmic journey. In a significant development for European space communications, Italy is in the final stages of negotiating a substantial €1.5 billion deal with SpaceX. This 5-year contract would revolutionize Italy's telecommunications security infrastructure, marking one of the largest European government contracts for SpaceX to date. The deal encompasses a comprehensive suite of encrypted communication services, leveraging SpaceX's satellite network to provide secure telephone and internet services for Italy's government operations. What makes this particularly noteworthy is the scope of services being considered, including dedicated military communications coverage across the Mediterranean region. One of the most promising aspects of this potential partnership is its focus on emergency response capabilities. The system would enable rapid deployment of satellite services during critical situations such as terrorist attacks or natural disasters, ensuring reliable communications even when traditional infrastructure might be compromised. The initiative has already received crucial backing from Italy's intelligence services and defense ministry, highlighting the strategic importance of this investment in national security infrastructure. This move aligns with Italy's broader efforts to modernize its communications capabilities and strengthen its position in the growing space sector. What's particularly interesting is that Italy isn't just focusing on security communications. The country is also planning to conduct tests to evaluate whether Starlink's satellite-based connectivity could help boost high-speed internet access across the nation. This dual-purpose approach could potentially transform both government operations and civilian internet infrastructure throughout Italy. Next, let's take a look at some groundbreaking research from the University of Virginia, which is pushing the boundaries of spacecraft propulsion technology. Led by Professor Chen Kui, the team is making remarkable advances in understanding electric propulsion thrusters, which could fundamentally change how we travel through space. Unlike traditional chemical rockets, electric propulsion systems work by ionizing xenon gas and accelerating it using electric fields. This process creates a high-speed plasma beam that propels spacecraft forward with remarkable efficiency. What makes this technology particularly exciting is that it allows spacecraft to travel much further while carrying significantly less fuel. The team's research focuses on the behavior of electrons within these plasma beams, which might seem like a minor detail, but is actually crucial for the future of space exploration. These tiny charged particles play a vital role in determining how the thruster's exhaust plume interacts with the spacecraft itself. Understanding these interactions is essential for missions that could last years or even decades. One of the most significant challenges they're addressing is how to prevent the plasma plume from damaging critical spacecraft components. When not properly managed, these particles can flow backward towards solar panels, communication antennas, and other sensitive equipment. By developing advanced computer simulations, the researchers are gaining unprecedented insights into how these particles behave and how to control them effectively. The implications of this research extend far beyond academic interest. As we look toward ambitious goals like NASA's Artemis program and future Mars missions, these improved electric propulsion systems could be the key to making long-duration space travel not just possible, but practical. Their increased efficiency and reliability could be the difference between a successful mission and one that falls short of its objectives. Particularly fascinating is how the team is using state-of-the-art supercomputers to create noise-free simulations that reveal previously unseen patterns in electron behavior. This deeper understanding is already leading to improvements in thruster design that could significantly extend the operational life of future spacecraft. Now let's move on to some more groundbreaking research, this time involving everyone's favorite space topic. In a fascinating breakthrough, astronomers have discovered that some massive black holes form in a surprisingly quiet way, without the spectacular explosions we typically associate with stellar death. This evidence comes from observations of a remarkable binary star system known as VFTS 243, located in our neighboring Large Magellanic Cloud galaxy. The system consists of a massive star about 25 times heavier than our Sun, orbiting with a black hole roughly 10 times our Sun's mass. What makes this discovery particularly intriguing is how it challenges our traditional understanding of black hole formation. Typically, we expect massive stars to end their lives in dramatic supernova explosions, but VFTS 243 tells a different story. Using state-of-the-art models of stellar collapse, researchers found that the black hole in this system likely formed through a process called direct collapse. Instead of exploding, the star essentially imploded, with most of its energy being carried away by tiny particles called neutrinos. This process is remarkably subtle compared to the cosmic fireworks we usually expect. The team's calculations revealed that these neutrinos were emitted almost equally in all directions during the collapse. This symmetrical emission is crucial because it explains why the binary system remained intact. A traditional supernova explosion would have likely torn the system apart, or at least significantly disrupted its orbit. This discovery opens up new possibilities for understanding how black holes form throughout the universe. It suggests that many stellar mass black holes might come into existence without announcing themselves with bright explosions, making them essentially invisible to our telescopes at the moment of their birth. The implications are significant for our understanding of stellar evolution and the population of black holes in our galaxy. It seems that nature has more than one way to create these cosmic giants, and sometimes prefers to do so quietly, without the dramatic flair we've come to expect from dying stars. As NASA and other space agencies prepare for a permanent human presence on the moon, they're facing an unexpected challenge: keeping accurate time. While this might sound simple, the physics of space make it surprisingly complex. NASA researchers have recently developed a new system of lunar time to address this critical need. Time actually flows differently on the moon compared to Earth, with lunar clocks ticking slightly faster due to the moon's weaker gravitational field. In fact, lunar time drifts ahead of Earth time by about 56 microseconds every day. While this might seem insignificant, these tiny differences can have major implications for navigation, communication, and coordination between lunar operations. The new timekeeping system incorporates Einstein's theories of relativity to account for these variations. It considers not only the moon's weaker gravity, but also its motion around Earth and the Sun, which introduces periodic time variations. Even local gravitational anomalies on the moon, known as mascons, need to be factored in as they subtly influence the flow of time across different lunar locations. This precision timing becomes crucial when you consider the ambitious plans for lunar development, with multiple space agencies and commercial companies planning to operate various elements on and around the moon, from landing systems and rovers to permanent habitats and research stations. Coordinated timekeeping becomes essential for everything from navigation to communication scheduling. The system also needs to maintain precise synchronization with Earth-based mission control while allowing for autonomous operations during periods when Earth isn't visible from lunar bases. It's a complex balancing act that requires accounting for relativistic effects while maintaining practical usability for lunar operations. As we prepare to establish a permanent human presence on the moon, this new timekeeping system represents a crucial step forward. It's another reminder that even seemingly simple aspects of space exploration often require innovative solutions to account for the complex physics of our universe. Speaking of NASA, recent images from NASA's Mars Reconnaissance Orbiter have captured fascinating new views of the InSight lander, which has been dormant on the Martian surface for 2 years now. These observations are providing scientists with valuable information about how dust moves and accumulates on the red planet. The images show that the lander, once a gleaming piece of technology, has now taken on the same reddish-brown hue as its surroundings, a testament to Mars' ever-present dust. By monitoring how dust collects on InSight's surface and how much gets swept away by winds and dust devils, scientists are gaining new insights into Mars's atmospheric processes. Particularly interesting are the numerous dust devil tracks visible in the area around InSight. These swirling Martian winds have been found to follow a seasonal pattern, being most active during the summer months and nearly absent in winter. The tracks they leave behind create a constantly changing pattern on the surface, like nature's own Etch-a-Sketch. The images have also revealed interesting details about impact craters on Mars, including those created by InSight's own landing thrusters. Initially dark brown, these small craters have gradually filled with dust and returned to the surrounding terrain's characteristic rust color. This process helps scientists better understand how quickly surface features on Mars can change and disappear under the influence of dust movement, while engineers continue to occasionally listen for signals from InSight in case a dust devil cleans its solar panels enough to revive it. No new communications have been detected. After 2 years of silence, NASA has announced they'll stop listening for signals shortly. Even in its retirement, though, InSight continues to contribute to our understanding of Mars through these orbital observations. Looking ahead to 2025, we're set for an incredibly busy year in space exploration, with a remarkable lineup of missions that will push the boundaries of our understanding of the solar system. The Moon is taking center stage early in the year, with multiple missions headed to our celestial neighbor. In January alone, we'll see the launch of 2 lunar landers, Firefly Aerospace's Blue Ghost, destined for the Mare Crisium, and iSpace's Hakuto R Mission 2, which will attempt to land in the Mare Frigoris. These missions will carry various scientific payloads and even a micro-rover to explore the lunar surface. Several heavy-lift rockets are making their debut this year, marking a significant advancement in launch capabilities. Blue Origin's New Glenn rocket is scheduled for its inaugural flight anytime now, while Rocket Lab's Neutron rocket will join the lineup later in the year. These new vehicles will greatly expand our ability to launch larger payloads into space. In the realm of planetary exploration, China is preparing for its ambitious Tianwen-2 mission, set to launch in May. This spacecraft will attempt something never done before, visiting both an asteroid and a comet on the same mission. It plans to collect samples from asteroid Kamawalawa in 2026, before heading to comet Pan-STARRS in 2034. We'll also witness several crucial planetary flybys throughout the year. The Europa Clipper will swing past Mars in March on its journey to Jupiter, while ESA's Bepi Colombo will make its final Mercury flyby this month. These gravitational assists are crucial maneuvers that help spacecraft reach their distant destinations. Back in Earth orbit, we might see the beginning of commercial space stations, with VAST's plans to launch their first Haven 1 module in August. Meanwhile, multiple space weather monitoring missions will take their positions to help us better understand solar activity and its effects on Earth. That brings us to the end of today's episode of Astronomy Daily. Thank you for joining me on this journey through the latest developments in space exploration and astronomy. If you'd like to stay up to date with all the latest space and astronomy news, head over to our website at astronomydaily.io, where you can sign up for our free daily newsletter and explore our constantly updating newsfeed. While you're there, you can catch up on all our previous episodes. Make sure to follow us on social media. You'll find us as Astro Daily Pod on Facebook, X, YouTube, YouTube Music, Tumblr, and TikTok. And if you're enjoying the show, please subscribe on your favorite podcast platform, whether that's Apple Podcasts, Spotify, YouTube Music, or wherever you prefer to listen. This is Anna reminding you to keep looking up, and I'll see you tomorrow for another fascinating look at what's happening in space.